we are going to start now the chapter 2 of class 11th mathematics, relations and functions. The first definition we have over here, it is ordered pair. So we have two numbers a and b, and they are listed in a specified order and enclosed in parentheses. So we are saying when we are writing these numbers as a comma b, this we are saying this is an ordered pair of the numbers a and b. What ordered pair means that their position it is fixed. The position of these numbers it is fixed. So a is called the first component. This a, it is called the first component, and b is called the second component of the ordered pair. So this thing also implies us that if we interchange the position of these numbers, then these are not equal to each other. As ordered pair, these two are not equal to each other. So this thing is specified over here that by interchanging the position of the components, the ordered pair changes. Next is what these can be representing. What these numbers are representing, we are saying the position of the point in a plane is determined by an ordered pair. So if we are talking about the number 2, 3, this is any point a we are saying. So it means it is on x-axis, this point is 2 units away from the origin. On y-axis, this is 3 units away from the origin. So what this thing means, that these position, this is representing the position on the x-axis, this is representing the position on the y-axis. So both these points, these are fixed. Next we have is equality of two ordered pairs. So we have two ordered pairs, say a comma b, one ordered pair, and we are saying this is equal to c comma d. Then what this thing means is that first component that is equal to the first component of the second, both the second component they are also equal. So what we get is that a is equal to c and b is equal to d. So based upon this, we have the following problem. We are saying we have to find a and b when these conditions, these are given to us. So from this condition, what we get is that the first component over here, that is 2a plus b, that should be equal to 1, and this 11 should be equal to a minus 3b. So we have 2a plus b is equal to 1 and a minus 3b is equal to 11, and we know how we solve these simultaneous equations. We are writing it is 2a plus b is equal to 1 and 2a minus 6b is equal to 22. Now if we subtract these equations, we get it is 7b is equal to minus 21. So this gives us b is equal to minus 3. If we substitute this value of b is equal to minus 3, say in this second equation, you will get a is equal to 11 plus 3b. So this is equal to 11 plus 3 into minus 3. So the answer comes out to be 2. So these are the values of a and b that we get. Next is express. This set is given to us as ordered pairs. So what is given over here is that x comma y belongs to w. W means we are talking about these are the whole numbers, and we are saying x square plus y square is equal to 25. So we want to find, what this thing means is we want to list the collection x comma y which satisfy this relation. So we are saying the first value of the x, suppose we are taking the values of x, we are saying x belongs to w. So the first value x can take, that is equal to 0. So when x is equal to 0, from this equation we will get that the value of y we will obtain, that will be equal to plus minus 5. And we know what is given to us is that y also belongs to w. So we are saying minus 5 is not possible. So the value of y we will get corresponding to 0. The value of y we will get it is 5. Next, suppose we are substituting x is equal to 1. So this gives us y is equal to, when you substitute 1 in this equation, It is 1 plus y square is equal to 25. So we are saying y square is equal to 25 minus 1, that is equal to 24. So this gives us y is equal to plus minus root of 24, square root of 24. So there is no value, there is no whole number that satisfies this relation. So we are saying there is no value corresponding to this y. We are saying there is no value over here. So we are saying that corresponding to 1 there is no value over here. Next value we will have when we will put x is equal to 3. Similarly for 2 no value will be there, it will be 2 square plus y square is equal to 25. So we will get y square is equal to 21. Again no value of y we will obtain, which is a whole number. We are saying there is no value of y which is a whole number. Next, if we put x is equal to 3, we will get it is 9 plus y square equal to 25. So the value of y we will obtain, that is equal to plus minus 4. Minus is not possible because y is a whole number. So we get y is equal to 4. So the value we will get it is 3 comma 4. That when x is equal to 3, y is equal to 4. Similarly, when we put 4, x is equal to 4, we will get y is equal to 3. So these are the final answers that we are obtaining. That the value of x is 0, 5, then y is 0. When x is 0, y is 5. When x is 3, y is 4. When x is 4, y is 3. So these are the only possible values, because if we put 6, x is equal to 6, or we are saying greater than equal to 6, then we cannot find any value. So these are the only possible answers in this case. Next definition we have, it is Cartesian product of two sets. So we are saying if we have two non-empty sets A and B, we are considering both these sets, these are non-empty sets, then the Cartesian product of A and B is the set A cross B. It is represented as A cross B. We are given two sets A and B. Cartesian product is represented as this. Then it consists of all ordered pairs. This set, it consists of all ordered pairs. Its elements are in the form of A comma B, where A belongs to A and B belongs to B. It means we have to make the ordered pairs by taking the elements of A. We are going to write the first component of this ordered pair. By taking the elements from B, we are going to write the second component of this ordered pair. And this is a definition for if A and B both are non-empty. If A or B, any of these is empty set, then A cross B is defined as the empty set. This is the definition. This complete is the definition. That if A and B are non-empty, then we are writing ordered pairs by taking first component from A and second component from B. Now, and if one of these sets is empty, then the ordered pair is also, the Cartesian product we are talking about, it is also empty. Another thing to note over here is that when we are talking about the Cartesian product, it is also a set. So this thing is important to note, that whenever we are talking about Cartesian product, we have to write the elements in these brackets because it is a set. Next we have is, if number of elements in A, the set A we are talking about, it is P, and number of elements in set P is equal to Q. So we are saying the number of elements in A cross B, that is equal to PQ, that is equal to number of elements in B cross A. So Cartesian product, basically we are saying, suppose we have two sets. A is the set having the element 1, 2. B is the set having the elements A, B, C. So we are writing the elements in this form. The elements of A we are writing on this axis, we are writing it is 1 and 2. Elements of B we are writing on this side, it is A, B and C. Now what we are going to do, we are going to write this first element over here. So that element will be 1 comma A. Next will be 1 comma B. next is 1 comma C. These are corresponding to these points. Next we will have, the next element we will have it is 2 comma A, next is 2 comma B, and next is 2 comma C. So these are the elements that we will have in the set Cartesian product of A cross B, that will be 1 comma A, 1 comma B, 1 comma C, then 2 comma A, 2 comma B, and 2 comma C. And if we have to write, so the number of elements we get, first we are talking about the number of elements. So number of elements, we are saying number of elements in A, that is equal to 2. Number of elements in B, that is equal to 3. So the number of elements in A cross B, that is equal to 2 into 3, that is equal to 6. Next is, if at least one of A and B is infinite, then the number of elements in A cross B or B cross A, they are also infinite. So based upon this, we have the following problems. First is, A is equal to, the set is given to be, A is equal to 1, 3, 5, and set B is given to be 2, 3. We have to find the value of A cross B. A cross B means we are talking about the Cartesian product over here. So we are saying the Cartesian product we have written over here. So what we have to do, we have to write these elements. This first element of A, it is 1. So with 1 we are writing the elements of B. It is 1, 2 and 1, 3. Then with this 3 we are writing both these elements. It is 3, 2 and 3, 3. And next with this 5 we are writing the elements 5, 2 and 5, 3. Similarly, we have to calculate B cross A. We are writing, this is B cross A. Now what we have to do, the first component over here, it is corresponding to, this is corresponding to first component should be from B. So we are writing, it is 2 over here. So the element we get, it is 2 comma 1, then it is 2 comma 3 and 2 comma 5. Next element of B, it is 3. So first component over here we have 3. So it is 3 comma 1, 3 comma 3 and 3 comma 5. So these are the elements that we have for B cross A. Now next thing we have to calculate over here, it is A cross B intersection B cross A. Now if we look at this element 1 comma 2, there is no element 1 comma 2 in this set. If we look at the element 1 comma 3, there is no element 1 comma 3. If we look at the element 3 comma 2, there is no element 3 comma 2 in this set. Similarly, if we are looking at this element 3 comma 3, this element 3 comma 3 is present over here. Then 5 comma 2 is not there, 5 comma 3 is not there. So the only common element we have over here, it is 3 comma 3. So the intersection of these two sets, it is 3 comma 3. Now next we are given the sets A and B, A, B and C. So this is the set A, 1, 2, 3. Set B is 3 comma 4. And set C, it is 4, 5 and 6. Now we have to calculate the value of A cross B intersection C, A cross B intersection A cross C, and A cross B union A cross C. Now the first part we have to calculate A cross B intersection C. Now what is the value of B intersection C? Look at these two sets over here. The common element over here, it is 4. So the set A is 1, 2, 3 and B intersection C, that is equal to the set 4. So we are going to write the Cartesian product. Cartesian product is a set. The first element we are taking from this, it is 1 comma, second element we will have, it is 4. Next it is 2 comma 4 and next it is 3 comma 4. So this is the Cartesian product of these two sets. Next is A cross B. Now the elements of A we have, it is 1, 2, 3. The elements of B we have, it is 3 comma 4. So in the Cartesian product we will have the elements 1 comma 3, then 1 comma 4. next it is 2 comma 3, then 2 comma 4, next it is 3 comma 3, and it is 3 comma 4. So these are the elements in this set. Now second thing we have to calculate is A cross C. So A has elements 1, 2, 3, B has elements 4, C has element 4, 5, 6. So the elements in this Cartesian product, that will be 1 comma 4, next it will be 1 comma 5, next it will be 1 comma 6. The next elements in this set we will have, it is 2 comma 4, then it is 2 comma 5, then it is 2 comma 6, then it is 3 comma 4, then it is 3 comma 5, and then it is 3 comma 6. So these elements, these are mentioned over here, that these are the elements in the first Cartesian product, these are elements in the second Cartesian product. Now we have to write the intersection and union of these two sets. So when we look at the intersection over here, the common elements we have, it is 1 comma 4, 1 comma 4 is there. Next we have 2 comma 4 and 2 comma 4, and next common element we have, it is 3 comma 4 and 3 comma 4. So this is the answer we are obtaining for the intersection. And when we have to write the union of these sets, so we are saying we have written all the elements of this plus these elements, 1 comma 3, 2 comma 3 and 3 comma 3, these are included in the union of these two Cartesian products. Now the next we have is, let A is equal to, this set is given to be, x is a natural number and x is the root of the equation x square minus 5x plus 6 is equal to 0. So x square minus 5x plus 6 is equal to 0. You can write it in the form x square minus 2x minus 3x plus 6 is equal to 0. So this gives us x is common, we are left with x minus 2, minus 3 is common, we are left with x minus 2 is equal to 0. So this gives us x minus 3 into x minus 2 is equal to 0. So we get x is equal to 3 or 2. So the solution set we have, it is 2 comma 3. Next we are saying the next set we have B. It is x belongs to W. X is a whole number and it is between 0 and less than 2. So the elements of this set B we have, it is 0 comma 1, and this set C we have x belongs to N, x is less than 3. So the elements of this set, it is 1 and 2. Now next thing we have to calculate, it is A cross B union C. So what is B union C? That will be equal to 0, 1, 2. This is the element B union C. And we have to prove that this is equal to A cross B union A cross C. So the value of A cross B that we have over here, these two sets, Cartesian product of these two sets, and A cross C we have, it is Cartesian product of these two sets. In this set we are saying the first element, it is 2. So the elements we are writing, it is 2, 0 and 2, 1. Next elements we are writing, it is 3, 0 and 3, 1. Similarly, if we write the Cartesian product of these two sets, the answer we have, it is 2, 1, 2, 2, 3, 1 and 3, 2. Now finally we are writing the Cartesian product of these two sets. So it is 2, 0, then 2, 1 and then 2, 2. We are saying it is 2, 0, 2, 1 and 2, 2. Next it is 3, 0, 3, 1 and 3, 2. So these are the elements over here. And when we write the union of these two sets, we are getting the same answer. So we are saying that this equality, it is satisfied over here. Now next question we have is, if A cross B is equal to the Cartesian product, it is given to us. We have to find the values of A and B. And we know that the first components over here, they represent A, and the second components over here, they will represent the elements of the set B. So the set we will have, it is first component, it is 3 and 5. So this is the set A, and the set B will be the second components. They are 2 and 4. So these are the sets A and B. Next is A and B are two sets given in such a way that A cross B contains 6 elements. Now we are saying number of elements in A cross B, that is equal to 6. If 3 elements of A cross B, they are 1 3, 2 5 and 3 3, find the remaining elements. Now if we look at these 3 elements, what we get is that A will have elements 1, 2 and 1, 2 and 3. There may be some other element also, may not be some other element also. First of all, we are not talking about how many elements A has. Now we are talking about the set B. The B will have elements, it is 3, 5, 3. So 3 and 5, we are sure that it will have these two elements. Now we are saying if A has more than this element, suppose it has number of elements in A that is equal to 4, then number of elements in A cross B, it cannot be equal to 6, because we know that number of elements in A cross B, that is equal to number of elements in A into number of elements in B. Now what are the factors of 6 we can have? It is 1 cross 6, that is A can have 6 element, B A can have 1 element, B can have 6 element. 2 cross 3, 3 cross 2 and 6 into 1. These are only possible ways. So we are saying that it is not possible that A can have any other element. So only elements in A, they are 1, 2 and 3. And it is not possible that there are other elements in B. So the only possible elements in B, they are 3 and 5. So we are saying it is satisfying this condition that A has 3 elements and B has 2 elements. Now if we have to write the Cartesian product of these two sets, the answer we will get, it is equal to 1 comma 3, 1 comma 5, then it is 2 comma 3, 2 comma 5, then it is 3 comma 3 and 3 comma 5. Out of this, 1 comma 3 is already listed over here, 2 comma 5 is already listed over here, and 3 comma 3 is already listed over here. So the remaining elements we have, they are 1 comma 5, 2 comma 3 and 3 comma 5. Next we have is, if A is equal to the set AB, we have to write the value of A cross A. So A cross A means, now the set we have, it is AB cross AB. First of all, we are taking the first component, it is A. The second component will be A and B. So the value of A cross B set, A cross A is, first we are writing A comma A, then A comma B. Next we have to take this element B, then it is B A and B B. So these are the elements of the Cartesian product A cross A. Next is, let R be the set of all real numbers. What does R cross R represent? So we are saying, suppose we have to write the value of R cross R. So we are considering the real numbers as the x-axis. Similarly, we are considering this y-axis. So these are the real numbers over here, 1, 2, 3, 4. There are real numbers over here, 1, 2, 3, 4. So when we are talking about R cross R, it means we will have some element over here. It is 1 comma 1. There may be some element over here. Some irrational numbers are also there. Some rational numbers are also there. Because we are talking about the real line, so any number we can take. Suppose we are talking about over here the number is square root 2. Over here the number is square root 2. So we will have the number over here that is root 2 comma root 2. So basically R cross R, it represents this complete plane. We are talking about R cross R, it represents this complete plane. We are talking about the real numbers, so negative side of these axes are also included. So we are saying what R cross R represent? It represents the complete XY plane, or in place of complete, this is not a mathematical term, so we are saying it represents the finite XY plane. At this stage you may leave this term also, you can just write it is the XY plane because we are restricted to the finite XY plane only. Next is, if A cross A has 9 elements, 2 of which are minus 1 0 0 comma 1, find the set A and the remaining elements of A cross A. Now we are saying number of elements of A cross A, that is equal to 9. Suppose the number of elements in A, that is equal to x. So we are saying this value is equal to x square. So the value of x we will have, that is equal to 3. Negative is not possible because it is number of elements over here. So we are saying the number of elements in A, that is equal to 3. Now these are the elements of the Cartesian product. We are saying if A is equal to minus 1, these elements, this element is from A, this 0 belongs to A, this 1 belongs to A. So A has 3 elements we are talking about, minus 1, 0 and 1. Then A cross A will have number of elements in A cross A, that will be equal to 9. Now A cross A will have elements, we are talking about it is minus 1, 0, 1 cross minus 1, 0, 1. So how we are going to write the element? We are considering this minus 1 as the first element over here. We are writing minus 1 comma minus 1. Next is minus 1 comma 0. Next is minus 1 comma 1. Next we are saying it is 0. This element we are considering 0. This is we are taking as the first coordinate. So it is 0 comma minus 1. Then it is 0 comma 0. And then it is 0 comma 1. Now last we have it is, we are taking this 1 as the first coordinate. Then we are writing it is 1 comma minus 1. Next is 1 comma 0. And next is 1 comma 1. So these are the 9 elements that A cross A has. So we have to write the remaining elements. So we are saying that minus 1 comma 0 is already listed and 0 comma 1 is already listed. So these are the remaining elements that the set A cross A has. Next we have given the graphical representation of A cross B and B cross A. So we are taking the x-axis over here. This is the x-axis. This is the y-axis over here. We have plotted these points. So two sets A and B, these are given to us. A is this set and B is this set. We have written the value of A cross B, that is equal to the set minus 1 comma 1, minus 1 comma 3, 2 comma 1, 2 comma 3, 4 comma 1 and 4 comma 3. And we have plotted these points over here. So it is minus 1 comma 1. So this is the point minus 1 comma 1. Then it is minus 1 comma 3. Then it is 2 comma 1. Then it is 2 comma 3. Then it is 4 comma 1. And then it is 4 comma 3. So these are the points we have plotted A cross B. Now if we have to plot the points of B cross A, we take B is equal to 1 3, A is equal to this. So the points that we have to plot, they are 1 comma minus 1. So the point 1 comma minus 1, it will be somewhere over here. Next is 1 comma 2. This is the point 1 comma minus 1. Next is 1 comma 2. So 1 comma 2 point that will lie somewhere over here. This is the point 1 comma 2. Next is 1 comma 4. So 1 comma 4 will be the point over here. So we are saying that if suppose we join all these points, We are getting a rectangle in this case in this form. Now we are plotting these 3 points. So the next points that we have to plot it is 3 comma minus 1. So it is 3 comma minus 1, 3 comma 2 and 3 comma 4. Now the rectangle that is formed is in this form. So basically what we are saying is that if we rotate these axes by 90-degree angles, if we have plotted these points, and we rotate it by 90-degree angle, that is we interchange x axis with y axis, then we will get the position or the graphical representation of the points B cross A. So we are saying when we are writing A cross B, this is represented on the x-axis, this is represented on the y-axis. When we are talking about B cross A, these points B they come upon on the y-axis and this point A they come on the x-axis. The next representation we have it is arrow diagrams. So suppose we have two sets, A is 1 minus 1 2 4 and B is 1 and 3. B has two elements. So we have written the value of A cross B and B cross A. When we are talking about the arrow diagram, we are saying we have two sets A and B. In A we have three elements minus 1, 2 and 4. In B we have two elements 1 and 3. So when we are talking about A cross B, we are saying that every element over here, it is joined to every element over here. Then 2 is joined to both these elements. Then 4 is joined to both these elements. Similarly, when we are writing B cross A, we are saying this is now this set B is there. It is 1 comma 3. These are the two elements. We have this set A. There are three elements minus 1, 2 and 4 over here. So we are talking about, we are taking this first element as 1. We have joined it to all the three elements over here. Next we have this element 3. We have joined it to all the three elements over here. So we get the answer. This is the graphic. This is the arrow diagram for this Cartesian product. This is the arrow diagram for this Cartesian product. Next definition we have is the ordered triplet. So we are saying if we have three numbers A, B and C listed in a specific order and enclosed in the parentheses, they form an ordered triplet. Just like the ordered pair, we are having ordered triplet. So if we are talking about any non-empty set A is there, then A cross A means we are saying it consists of an ordered triplet such that this A comes from A, then this B comes from A and then this C comes from A. So this set A is given to be 1 comma 2. We have to write 1 comma 2 cross 1 comma 2 cross 1 comma 2. So how we are going to write this is, first of all we are solving these two values. We are taking the Cartesian product of these two values. So this will be a set and the answer will be 1 comma 1, 1 comma 2. Next elements will be 2 comma 1 and 2 comma 2. Now we have Cartesian product with the set 1 comma 2. So when we take the Cartesian product now, so we are saying the first element now we have it is 1 comma 1. We have to take the product with 1, then we have to take the product with 2. So the elements we will have it is 1 comma 1 comma 1, 1 comma 1 comma 2. Next we will take the second element 1 comma 2. We will take the product with these two elements. So it is 1 comma 2 comma 1 and 1 comma 2 comma 2. Next element we have it is 2 comma 1. So it is 2 comma 1 comma 1 and 2 comma 1 comma 2. And last we have it is 2 comma 2 comma 1 and 2 comma 2 comma 2. So these are the elements of A cross A cross A. Next we have is let R be the set of all real numbers what does R cross R cross R represent? We have already seen that when we are talking about R cross R, this is our x-axis, this is our y-axis, this is the plane it is representing. It is a complete xy plane or finite xy plane is there. This is the xy plane. This is R cross R that is representing. Now we are taking the Cartesian product with another R. It means there is another direction over here. We are saying that is the z axis. So what we get is, when we are talking about this z axis, so R cross R that is representing the coordinates of the points in the three-dimensional space. So this xy plane, we are saying this is the two-dimensional plane. This R cross R will represent the three-dimensional, any point in the three dimensions. And this is called the three-dimensional space. Over here the term we are using it is plane. Over here the term we are using it is space. Now the next question we have is, this set A is given to be 1, 2, it has two elements. B has the elements 3, 4 and C has the elements 4, 5. Now we have to calculate the value of A cross B cross C, and we have to prove that this is equal to A cross B cross C. So this thing is shown over here. We have taken A, B and C. Now if we take the product of A and B first, we will get the Cartesian product as 1, 3, 1, 4, 2, 3, 2, 4. Then we have multiplied, we have taken the Cartesian product with 4, 5 and we obtain this answer. Similarly, we can show that if we take the Cartesian product of 3, 4 first, we will get this set over here. Now we are taking the Cartesian, the product with 1, 2, and it is easy to verify that we are getting the same answer in both these cases. So you can try this at your own and you will obtain that both these values, these are equal to each other. Next we have is, set A is given to be having elements 2, 3, B has the elements 4, 5. We have to write the value of A cross B. So the value of A cross B that we have, it is 2, 4, 2, 5. This is 2, 4, 2, 5, then 3, 4 and 3, 5. Next we have to write how many subsets will A cross B have. We have to calculate, this is a set and we have to tell how many subsets this set has. So number of elements in A cross B, that is equal to 4. So the number of subsets A cross B will have, that is 2 raised to the power 4, that is equal to 16. Next is, let A cross B is equal to, this value is given to be, it is collection of all those A, B such that B is equal to 3A minus 2. If x comma minus 5 and 2 comma y, these are the two values we are talking about, they belong to A cross B. Find the value of x and y. So what this thing means is, this value satisfies this equation. So what we are saying is that if we take A is equal to x and B is equal to minus 5, then we will have B is equal to 3A minus 2. That is, minus 5 is equal to 3x minus 2. So 3x is equal to minus 3. So you will get the value of x is equal to minus 1. Next, in the second step, we are saying when A is equal to, we are considering the second value, we are saying A is equal to 2 and B is equal to y, then both these values, they will again satisfy this relation. So we will have y is equal to 3 into 2 minus 2, that is equal to 6 minus 2, that is equal to 4. So what we have is that the value of x we have, that is equal to minus 1, and value of y we have, that is equal to 4. Now next we have is, let A and B be two sets such that Number of elements in A is 3 and number of elements in B is 2. If A is not equal to B is not equal to C, this condition is given to us, and A comma 0, B comma 1 and C comma 0 are in A cross B. We have to find the value of A and B. So if we look at these elements over here, what we get is that the elements of A, they are A, B and C. These first elements we are talking about, these are the elements of A because these are the values of A cross B, and the elements of the set B, they are 0 and 1. So these are the values of, or these are the sets A and B that are required. Next we have is let A is equal to, it is minus 3 comma minus 1, B is equal to 1 comma 3 and C is equal to 3 comma 5. We have to calculate the value of A cross B cross C. So when we are calculating A cross B, we are saying it is minus 3 comma 1 minus 3 comma 3. The next values we have, it is 1 comma minus 1 comma 1 and minus 1 comma 3. So this is the value of A cross B. Now next we have to calculate the value of A cross B cross C. So this is the value A cross B, and we have to take the Cartesian product with 3 comma 5. So what we have to do, this is the first element we are considering from A cross B. So when we take the Cartesian product with C, we are saying this is multiplied with C, first element 3 and then it is multiplied with next element 5. So the elements we will write is minus 3, 1, 3 and minus 3, 1, 5. Next we have to consider the second element. We have to take the Cartesian product with these two. It is minus 3, 3 and 3. Next element is minus 3, 3 and 5. Next we are writing this element, it is minus 1 comma 1. We have to take the product with these two. So it is minus 1, 1, 3 and minus 1, 1 and 5. And the last part we will have, it is this element minus 1, 3 we are considering, and we are taking the product with this 3 and 5. So it is 3 comma 5 over here. So these are the elements of this set that we have to calculate, A cross B cross C. Now the next question we have is, if A is a subset of B, then we have to prove that A cross C is a subset of B cross C. So we try to visualize this situation graphically. So we are saying, suppose this line, this is representing the elements of the set B, and it is given that A is a subset of B, and we are considering that this portion out of this line, this is the set A. We are talking about the intervals A. Then we have another set C over here. This is the set C we have. Now what is B cross C? So B cross C means we are talking about this is the portion we are saying. This is the line corresponding to this. This is the line corresponding to B. So the portion corresponding to B cross C will be this portion. This is the portion, this yellow portion we are showing. This is the portion which represents B cross C. Next we have this line A is there. So corresponding to this A we have this thing. So the portion corresponding to A cross C will be this portion. This is A cross C. So if we are talking about the intervals, these are the rectangles which we obtain as the Cartesian product. So this is a particular case, this is a particular example, this is not the proof. This is just to make you understand that what is happening over here. So now to give the general proof, we are saying it is given that A is a subset of B. Now we have to prove that A cross C is a subset of B cross C. So we consider an element of A cross C. The elements of A cross C, they will be of the form A comma C. This will belong to A cross C. This will belong to A cross C. If we take any element from here, the element will be A comma C. A will be from this, C will be from this side. Now, what this thing means is that A belongs to A and C belongs to C. Now it is given that A is a subset of B. It means this A will belong to B and C will belong to C. So what this thing means is that A comma C, this will belong to B cross C. So what we get is that for any element A comma C belongs to A cross C, A comma C belongs to B cross C. So this thing gives us that A cross C is a subset of B cross C. Next is, if A is a subset of B and C is a subset of D, we have to prove that A cross C is a subset of B cross D. So we consider an element from A cross C. The element of A cross C will be of the form A comma C belongs to A cross C. So this thing implies that A belongs to A and C belongs to C. Now it is given that A is a subset of B. It means if A belongs to A, this thing implies that A belongs to B. So what we can write, this thing implies that A belongs to B and C belongs to D. Because of this condition, we are saying C belongs to D. So this thing gives us A cross C. This belongs to B cross D. So this thing proves that for A comma C belongs to A cross C, A comma C belongs to B cross D. It means A cross C is a subset of B cross D. Next we are given is that A and B, these are two non-empty sets. We have to prove that A cross B is equal to B cross A. This implies A is equal to B. So this is implies and implied that, so it is if and only if condition. So in the first part we are assuming that A is equal to B. Then clearly A cross B is equal to, in place of A we can write it as B. In place of this B we can write it as A. We are replacing this B, this A with this B and this B with this A, and we obtain this is equal to B cross B. So we are saying if A is equal to B, then this result is true, because it will become A cross A is equal to A cross A, or it will become B cross B is equal to B cross B. Conversely, we are saying, suppose this thing, this holds. It is given that A cross B is equal to B cross A. Now we have to prove that A is a subset of A is equal to B. It means we have to prove two things. One is A is a subset of B, and second we have to prove is that B is a subset of A. Now to prove this first part, suppose we are saying there is an element A which belongs to A. Now we have to prove that this element, it also belongs to B. So if A belongs to A, so this thing implies us that A comma B, it belongs to A cross B for some B in B. Now it is given that A cross B, that is equal to B cross A. So it means A comma B, this belongs to B cross A. So this thing gives us that A belongs to B. This is, we are writing A belongs to B and B belongs to A. This thing implies us that A belongs to B. So what we get is, we have started with A, some A belongs to A. We are getting that A will belong to B. So it means this thing proves that A is a subset of B. Similarly, when we have to prove the second part that B is a subset of A, we are assuming an element B in B, and we are obtaining that this B belongs to A. So by combining these two results, we obtain that B is a subset of A. From this we are obtaining A is a subset of B. By combining these two, we will get A is equal to B, and this is what we have to prove. Now the next we have is for any sets A, B and C, we have to prove that A cross B union C, that is equal to A cross B union A cross C. So again we have to prove this in two parts. We have to prove that this first set is a subset of second, and second, this is a superset of the second set. So to prove this first part, we are considering an element from this set. Suppose the element of this set, we are saying this set is A cross B union C. So the elements of this set will be of the form A comma B. It is Cartesian product of two sets. So that set A comma B belongs to B union C. So we are getting, this thing implies us that A belongs to A and this B belongs to B union C. So this thing gives us that A belongs to A, and in the bracket we are getting B belongs to B or C belongs to this B belongs to C. We are having this condition over here. Now by using the distributive property over here, we are getting it is A belongs to A and B belongs to B, or A belongs to A and this B belongs to C. So what this thing means is that A belongs to A and B belongs to B. This thing implies that A comma B belongs to A cross B, or A comma B belongs to A cross C. So what this thing implies is that A cross B union A cross C, the element A comma B, this belongs to this. So what we have started is that this A comma B, it belongs to the set A cross B union C, and we are saying this A comma B, it belongs to A cross B union A cross C. So we have proved that this set A cross B union C, this is a subset of A cross B union A cross C. Now to prove this second part, that is to prove that this set is a subset of this, we are saying all these signs, all these equivalent terms we are talking about or expressions we are talking about, these are basically with the if and only if conditions. So basically we are writing them in this way. So we start with this term, we are writing it is A comma B belongs to A cross B union A cross C. From this we can write that A comma B belongs to A cross B or A comma B belongs to A cross C. From this we can write this step, from this we can write this step, we can write this step, and we will obtain that A comma B belongs to A cross B union C. So this thing gives us that A cross B union A cross C, that is a subset of A cross B union C, and by combining both these results we are getting the equality sign over here. Next we have for any sets A, B and C, we have to prove that A cross B intersection C, that is equal to A cross B intersection A cross C. So if we consider the element A comma B, it belongs to A cross B intersection C. So what we get is that A belongs to A and B belongs to B intersection C. Now this thing implies that A belongs to A and B belongs to B and B belongs to C. So this thing implies that A belongs to A and B belongs to B and A belongs to A and B belongs to C. So this thing implies us that A comma B, it belongs to A cross B, and A comma B, this belongs to A cross C. This gives us A comma B, it belongs to A cross B intersection A cross C. So what we get is that this set A cross B intersection C is a subset of this set. Now next we are saying all these signs we are talking about implied that signs, these can be reversed also. So we are writing this proof over here. This proof is mentioned over here. These are basically these steps. These steps we have written in the reverse order, and we obtain that this set A cross B intersection A cross C is a subset of the second set. So by combining both these two results, we obtain the equality over here. We are saying both these sets, these are equal to each other. Next we have is for any sets A, B and C, we have to prove that A cross B minus C, that is equal to A cross B minus A cross C. So we are saying, let again we have to, this equality is there, so we have to prove that this is a subset of this first, and then we have to prove that this is a superset of this set. So if we look at this element over here, it is A cross B minus C. So the element over here that will be of the form A comma B, and we are saying that it belongs to A cross B minus C. So it means A belongs to A and B belongs to B minus C. So this thing implies us that A belongs to A and it is bracket over here, and we are saying it is B belongs to B and B does not belong to C. So this thing implies us that A belongs to A and B belongs to B and A belongs to A and B does not belong to C. So this gives us that A comma B belongs to A cross B and A comma B, it does not belongs to A cross C, because this B does not belong to C. It means this B is not the element of C, so it means A comma B is not the element of A cross C, because for A comma B to be element of this, B should be an element of C. So what this thing implies us that A comma B, it belongs to A cross B, it is element of this minus A cross C. So we have proved that this A comma B, it belongs to this set, then this A comma B also belongs to this set over here. So we are saying that this first set is the subset of the second set. Next we have is, we have to prove the opposite part. We are saying we have to prove this second is the subset of the first. So we are considering again over here the elements, they are A cross B over here. We are saying let A comma B belongs to this set. Then we will have, moving on to this next step, we are saying A belongs to A cross B and A comma B belongs to A cross C. Next, moving on to this step, we obtain this result. Moving on to next step, we obtain this result. Moving on to next step, we obtain this result, and we obtain that A comma B belongs to A cross B minus C. So we have proved that A cross B minus C is a subset of A cross B minus A cross C. Similarly, we have proved that A cross B minus A cross C is a subset of A cross B minus C. Combining these two results, we obtain that both these sets these are equal to each other. Next we have is four sets A, B, C and D are given to us, and we have to prove that A cross B intersection C cross D, that is equal to A intersection C cross B intersection D. So again the elements over here, they are in the form of Cartesian products. So if we consider two elements over here, so we are considering the elements of this set. It is, we are saying it is A comma B. It belongs to A cross B intersection C cross D. So what this thing means is that A comma B, it belongs to A cross B, and A comma B, it belongs to C cross D. Now if A comma B belongs to this, it means A belongs to A and B belongs to B, and it is and A belongs to C and B belongs to D. We have these two parts over here. So it is all and in between these terms. So we can shift the brackets or we can shift the term. So we obtain it is A belongs to A and A belongs to C and B belongs to B and B belongs to D. So this thing implies us that A belongs to A intersection C and B belongs to B intersection D. So this gives us that A comma B, this belongs to A intersection C cross B intersection D. Again, in all these results, all these terms we are writing or expressions we are writing, they are with the if and only if conditions. We can move from this step to this step to this, and this step to this. So we obtain that in the first part when we are moving, we have considered A comma B belongs to this. We have proved that A comma B belongs to this. We are saying this implies this thing, this is implying this part. So this proves that this set is a subset of this set. When we are saying A comma B belongs to this and we are proving that A comma B belongs to this, it means we are proving that this is the superset. So combining these two results, we are saying that these two sets these are equal to each other. Next is for any sets A and B, we have to prove that A cross B intersection B cross A, that is equal to A intersection B cross B intersection A. So now again we are considering an element A comma B which belongs to A cross B intersection B cross A. So in the previous result we have proved that A cross B intersection C cross D, that is equal to A cross C intersection B cross D. We have proved this result. So if we compare these two results, so basically what we are saying that B is equal to C if we substitute. If we take C is equal to B and we take D is equal to A, we will obtain this side over here. So if we substitute these values in this result, we will obtain it is, in place of C we are writing it is B and in place of D we are writing it is A. So we will obtain this side of the result. So this is just a special case of our previous result. The proof is exactly same. This proof that is given over here, this is exactly same as the previous result, that but the only difference is that in place of C we are writing C is equal to B and D we are writing D is equal to A, and we are getting the result in this form. Next result we have is if A and B are two non-empty sets having n elements in common. We are saying there are two sets A and B and they have n elements in common. Then A cross B and B cross A have n square elements in common. So this thing you must remember. So based upon this we have, let A and B be two non-empty sets such that number of elements in A is equal to 5, number of elements in B is equal to 6, and number of elements in A intersection B is equal to 3. Then we have to find the number of elements common between A cross B and B cross A. So we are saying the number of elements in A cross B, that will be equal to product of the number of elements in A and B, that is 30. Number of elements in B cross A, that is product of these two, and that is equal to 30. The number of elements common between the intersection or between the A cross B and B cross A, that is equal to 9, and it is given by this formula n square. So the value of A, number of elements common to AB, it is 3. So the number of elements in the intersection of A cross B and B cross A, that is equal to 9. Next is, if A, B and C be three non-empty sets given in such a way that A cross B is equal to A cross C, we have to prove that B is equal to C. So it is being given that A cross B is equal to A cross C. We have to prove that B is equal to C. So again, to prove B is equal to C, we have to prove B is a subset of C and C is a subset of B. So we consider any element B from B, and this thing implies us that A comma B will belong to A cross B for some A, or for every A belongs to A, because this B belongs to B. Now it is being given that this A cross B, that is equal to A cross C. So it means we can write A cross B that belongs to A cross C. So this thing gives us that A belongs to A and B belongs to C. So this thing implies us that B belongs to C, and this is what we are saying, that for B belongs to B, B belongs to C. So this thing proves that B is a subset of C. Similarly, if we consider an element C in C and we are taking the Cartesian product with the set A, then we are replacing this A cross C with A cross B, because it is being given that both these are equal to each other. So we obtain C belongs to B. So for C belongs to C, we have C belongs to B. It means C is a subset of B. So we have proved two results. One is B is a subset of C. Second, C is a subset of B. So combining these two results, we will get B is equal to C.